June 1942. The Crimean Peninsula. Soviet defenders huddle in tunnels carved 30 meters beneath Severnaya Bay, protected by layers of reinforced concrete. They have held Sevastopol for 8 months against everything the Wehrmacht can throw at them. They believe they are safe down here. They believe nothing can reach them. Then the earth shakes. Not like artillery, not like bombs, something deeper, something that makes the rock itself groan. 8 shells bore through the bay above them, through water, through seabed, through stone. The 9th finds them. The ammunition magazine erupts like a volcano, vaporizing men who never heard the weapon that killed them. 16 kilometers away, a deployment of thousands surrounds the largest caliber rifled weapon ever used in combat, 80 centimeters wide, 32 meters long. 1,350 tons of steel. They call it Schwerer Gustav, Heavy Gustav. And they have just witnessed the clearest demonstration in its entire existence of what this weapon was designed to do. What happens next explains why this gun, this monument to engineering ambition, this steel giant that took 5 years to build and 5 weeks to emplace, fired just 47 shots in the entire Second World War. It solved a problem Germany did not end up needing to solve, and it created logistics Germany could not afford. This is the story of Germany's ultimate superweapon, and why it was obsolete before it ever fired a shot in anger. The problem began with concrete, specifically French concrete. In 1934, German military planners stared at intelligence reports describing the Maginot Line and felt genuine fear. The French had spent years constructing the most formidable defensive fortification in human history, underground bunkers with massively reinforced walls, artillery casemates buried beneath hills, interconnected tunnels stretching for kilometers. Command centers protected by layers of steel and stone that no existing weapon could penetrate. The conventional wisdom held that any German attack would shatter against these defenses, like waves against a cliff. The German Army High Command issued a challenge to Krupp, the industrial giant that had armed Germany since the days of Bismarck. Design a weapon capable of destroying the Maginot Line, not damaging it, not suppressing it, destroying it utterly. The specifications assumed the gun must be capable of penetrating up to 7 meters of reinforced concrete, or 1 meter of steel armor plate, the maximum protection German planners believed they might encounter. Dr. Erich Müller, a Krupp physicist, ran the calculations. The numbers were staggering. To achieve the required penetration demanded a shell weighing 7 tons, fired from a barrel 30 meters long, with a caliber of 80 centimeters. Nothing like this had ever been attempted. The largest artillery piece of the First World War, Big Bertha, had a caliber of 42 centimeters and fired shells weighing 800 kilograms. What Müller proposed was a weapon firing shells nearly 9 times heavier from a gun twice as large. Krupp's engineers embraced the challenge with the enthusiasm of men who did not yet understand what they were creating. Initial designs appeared in 1935. Fabrication began in 1937. The timeline stretched and stretched again as engineers confronted problems no one had ever solved. How do you machine a barrel 32 meters long with tolerances measured in fractions of a millimeter? How do you build a breech mechanism capable of containing the pressure of a charge designed to hurl 7 tons of steel 47 kilometers? How do you transport something weighing more than 1,000 tons to a battlefield and assemble it under wartime conditions? Each question spawned dozens more. Each answer revealed new complications. Each solution demanded further innovation. Adolf Hitler visited the Krupp factory in March 1936 and became personally invested in the project. He walked among the massive forgings and half-finished components with the expression of a man beholding something sacred. He authorized millions of Reichsmarks in development funding, an enormous sum that would grow as the project expanded beyond all initial estimates. He demanded the gun be ready by March 1940, in time for the planned invasion of France. His engineers nodded and said nothing about the impossibility of this deadline. They missed it by more than a year. Component testing at the Hillersleben Proving Ground dragged through 1939 as one technical problem after another emerged. The first complete test round was not fired until September 1941. By then, the strategic situation had changed completely. The Wehrmacht had invaded France in May 1940 and simply driven around the Maginot Line through Belgium. The fortifications that had justified Gustav's existence were bypassed without a single shot from the supergun that was supposed to destroy them. A weapon designed to break through the strongest defenses in Europe had lost its purpose before it ever left the factory. Any rational military organization would have cancelled the project and redirected resources elsewhere. But Gustav had become something more than a weapon. It had become a symbol. Hitler called it his steel fist. Cancellation was unthinkable. So Germany continued pouring resources into a gun, searching for a target worthy of its capabilities. They would find one on the shores of the Black Sea, in a city that had already held against German assault for the better part of a year. The technical specifications of the Schwerer Gustav reveal both extraordinary engineering achievement and fundamental operational absurdity. Understanding these numbers is essential to grasping why this weapon represented such a spectacular misallocation of resources. The gun's caliber of 80 centimetres, 31.5 inches, made it the largest caliber rifled weapon ever used in combat. To put this in perspective, a standard German infantry rifle had a caliber of 7.92mm. Gustav's bore was more than 100 times wider. A grown man could crawl inside the barrel with room to spare. The shells themselves were larger than many automobiles of the era. The barrel stretched 32.48 meters, longer than a blue whale, longer than most houses. Each component had been manufactured to exacting standards that pushed the limits of 1930s industrial capability. The complete weapon weighed 1,350 tons assembled, stood 11.6 meters tall, roughly the height of a four-story building, and stretched 47.3 meters from end to end. Two types of ammunition were developed, each representing an extreme of artillery design that had never been attempted before. High explosive shells weighed 4,800 kilograms, roughly the weight of a large elephant, and could reach targets 47 kilometers away at a muzzle velocity of 820 meters per second. The explosive filling alone weighed several hundred kilograms. Upon impact, these shells created craters 10 to 12 meters wide and equally deep, obliterating everything within the blast radius. Buildings simply ceased to exist. Fortifications were torn apart. Nothing above ground could survive the impact zone. But the truly remarkable ammunition was the armor-piercing round. Weighing 7,100 kilograms, heavier than a fully loaded Indian elephant, these shells were designed to penetrate up to 7 meters of reinforced concrete or 1 meter of steel armor plate. They were built specifically to reach targets buried deep underground, to find men who believed themselves safe in tunnels and bunkers and prove them catastrophically wrong. On paper, in theory, no fortification of the era could withstand a direct hit from Gustav's armor-piercing shell. The mathematics of penetration seemed to guarantee destruction. Each shell stood between 2.5 and 4.2 meters tall, taller than two grown men standing on each other's shoulders. Loading them required a complex choreography involving hydraulic rams, specialized hoists, and crews trained for months in procedures that could not tolerate error. A single mistake in handling 7 tons of high explosive would end careers and lives simultaneously. The ammunition storage alone required dedicated railway carriages maintained at precise temperatures to ensure propellant stability. The rate of fire tells the story of Gustav's impracticality more clearly than any other statistic. 1 round every 30 to 45 minutes. Maximum daily output of 14 to 16 shells under optimal conditions. A standard German field howitzer of the period could fire 8 rounds per minute. In the time Gustav fired a single shot, conventional artillery could deliver nearly 500 shells on target. To achieve even this glacial rate of fire required preparations that bordered on the absurd. 20 physicists and engineers used infrared devices to measure propellant temperature, ensuring the powder charges stored in climate-controlled railway carriages remained at exactly 15 degrees Celsius. Wind speed at altitude was calculated using weather balloons. Atmospheric pressure was recorded with precision barometers. Chamber temperature was verified. Air density was factored into trajectory calculations. Only when every variable had been measured and compensated for would the firing sequence begin. The shell would rise on hoists up one side of the massive breech, while powder bags ascended the other. Hydraulic rams would seat the projectile and charge. The barrel would elevate to the calculated angle, its massive weight shifting on precisely engineered supports. And then, finally, the gun would fire with a sound that witnesses described as unlike anything else in the war, a rolling thunder that seemed to come from everywhere at once, accompanied by a shockwave that could be felt kilometers away. The numbers tell a story of disproportion that verged on the insane. Gustav's shell weighed 479 times more than standard German field artillery ammunition. The gun itself weighed 680 times more than a conventional howitzer. The crew required to operate, it could have manned an entire artillery battalion of 24 guns, each of which could fire dozens of rounds in the time Gustav managed one. The resources consumed in its construction could have produced well over 100 Panzer IV tanks. The steel alone, 1,350 tons, could have built more than 50 Panzer IIIs. The labour hours consumed would have assembled hundreds of aircraft. Consider what Germany actually built. A weapon that fired 1 shell every half hour, requiring thousands of men to operate, taking 5 weeks to prepare the site and emplace, moving only on specially constructed railway tracks, visible from kilometers away, vulnerable to any aircraft that discovered its location. This was not a practical weapon of war. This was a monument to the dangerous belief that bigger always means better. Moving Gustav required an operation that resembled a military campaign in itself. The gun travelled, disassembled, across 5 separate trains, stretching 1.5 kilometers in total length. 25 freight cars carried the gun components. Additional trains transported the artillery unit itself. Further trains carried ammunition in climate-controlled carriages, supply material sufficient for extended deployment, and mobile workshops capable of performing field repairs on the most complex artillery mechanism ever devised. The locomotive requirements alone would have served an infantry division. The railway infrastructure demands were extraordinary and inflexible. Gustav needed 4 parallel tracks at its firing position. 2 inner tracks supported the gun itself, which rode on 80 wheels distributed across 40 axles, the weight carefully balanced to prevent any single point from bearing excessive load. 2 outer tracks carried the 110-ton gantry cranes essential for assembly. Because the weapon had no built-in traverse mechanism, horizontal aiming required moving the entire 1,350-ton assembly along curved track sections. At Sevastopol, engineers constructed 4 semicircular shooting tracks allowing different firing arcs, an enormous earth-moving project undertaken under wartime conditions. Site preparation consumed 4 to 5 weeks with more than 2,000 workers laying reinforced tracks and excavating protective positions. The tracks had to be perfectly level and precisely gauged, able to support the massive weight without deformation. At Sevastopol, workers dug an 8-metre deep cutting through terrain, a vast trench that would contain the weapon and provide some protection from aerial observation. They covered the position with camouflage netting and flanked it with dirt mounds for additional concealment. Final assembly of the gun itself required approximately 54 hours with 250 specialists and both massive gantry cranes working continuously, piece by piece, raising the components into position and connecting them with precision that allowed no margin for error. The personnel requirements defied military logic. The heavy artillery unit E672, established in January 1942, comprised approximately 1,400 men as its core complement. But this was merely the beginning. Full deployment demanded several hundred men for direct firing operations, soldiers trained specifically in the elaborate procedures of loading and aiming. Assembly specialists possessed the skills to construct and deconstruct the weapon in the field. More than 2,000 track layers and site preparation workers performed the earth-moving and rail construction necessary before the gun could even arrive. Hundreds of men in flak battalions provided anti-aircraft defense, essential protection for a weapon that would be useless if enemy aircraft found and bombed it during its lengthy setup process. Guard companies secured the perimeter against ground attack or sabotage. Add crop engineers and scientists for performance evaluation, and the total approached 4,000 personnel for a single artillery piece. If you are finding this examination of military history interesting, consider subscribing to support the channel. Now let us see what happened when Gustav finally met its target at Sevastopol. Sevastopol in 1942 was the most heavily fortified port on the Black Sea, a city whose defences had been prepared over decades to resist naval and land assault. Soviet defenders had transformed the natural advantages of the terrain into a layered defense system incorporating coastal batteries designed to sink attacking fleets, underground magazines storing thousands of tons of ammunition, reinforced bunkers, housing command posts and communication centres, and networks of tunnels connecting strongpoints throughout the region. The terrain itself favoured defence, with hills and ravines providing natural obstacles that conventional assault would struggle to overcome. The garrison had held against German attacks since October 1941, tying down forces desperately needed on other fronts, bleeding the attackers with every assault, making the Germans pay for every metre of ground. German planners decided that Sevastopol justified Gustav's existence. Here was a target worthy of the ultimate supergun. Here were fortifications that conventional artillery could not reduce, bunkers buried too deep for normal shells to reach. Here, finally, Gustav would prove its value after years of development and months of preparation. The deployment began in February 1942. The unit departed with Gustav in pieces, travelling by rail toward the Crimean Peninsula through a transport network already strained by the demands of the Eastern Front. They arrived at the Perekop Isthmus in early March and began the laborious process of moving into position. Through April, engineers constructed a special 2-kilometre railway spur 16 kilometres north of the intended targets, laying track across terrain that had never been intended to support such infrastructure. In May, the gun itself was assembled in the excavated cutting that would serve as its firing position, the process consuming weeks of labour by hundreds of specialists. 5 weeks of preparation, thousands of men, kilometres of specially constructed track, mountains of earth moved and shaped to conceal and protect the weapon, all for a weapon that would fire its first combat round on June 5th, 1942. The daily engagement record survives in German military archives, a clinical accounting of destruction. On June 5th, Gustav fired 8 rounds at coastal battery positions, eliminating guns that had harassed German forces for months. That same day, 6 rounds struck Fort Stalin. All 14 targets were destroyed. On June 6th, 7 rounds struck Fort Molotov, reducing it to rubble in a bombardment lasting hours. That same day, 9 rounds targeted the White Cliff ammunition magazine beneath Severnaya Bay. This was Gustav's moment of triumph, the vindication of years of engineering and millions of Reichsmarks. The magazine lay deep underground, protected by substantial concrete positioned beneath the waters of the bay itself. Soviet defenders had reason to believe it invulnerable. Nothing in the history of warfare could reach targets buried so deep. 8 armor-piercing shells bored through water and seabed and stone without reaching their target, each impact bringing the gun crews closer to despair. The 9th found the magazine. German author Gerhard Tauber, who wrote the definitive account of these weapons in his 1979 book, called this the only absolutely verifiable bombardment with significant success. The fort erupted like a volcano. Men died without ever knowing what killed them, vaporized in an explosion that could be seen kilometers away. On June 7th, 7 rounds struck the Südwest Spitzer fortification. On June 11th, 5 rounds knocked out Fort Siberia. On June 17th, 5 rounds devastated the Maxim Gorky fortress complexes. And then Gustav fell silent. 47 rounds in 13 days. The gun's entire combat career compressed into less than 2 weeks. Accuracy was disappointing given the elaborate preparation required. Despite the extensive calculations by physicists and engineers, despite the precise measurements and careful compensation for every variable, many shells landed far from their intended targets. Each shell's massive destructive radius compensated somewhat for this imprecision, but the pinpoint accuracy expected from such an elaborate weapon was never achieved. The barrel was worn out. Design specifications called for roughly 100 rounds before replacement, but significant wear appeared after combat shots added to the approximately 250 test rounds fired during development. The rifling that stabilized the massive shells in flight had eroded under the tremendous forces of firing. The barrel was shipped back to Krupp for relining, a process that would take months. Gustav would never fire in combat again. Other deployments were planned but never materialized, the weapon spending the rest of the war in preparation or transit or storage. Gustav was fully assembled near Leningrad in the winter of 1942-43, positioned to reduce that city's defenses just as it had destroyed Sevastopol's. The gun never fired a single round. The attack was cancelled due to changing tactical conditions, the front shifting before Gustav could be brought into action. The gun's sister weapon, Dora, was transported to the Stalingrad area and reportedly prepared for action in September 1942. Dora retreated without firing when Soviet encirclement threatened to trap it, the most powerful artillery piece in history fleeing before an enemy advance. Claims that Gustav fired during the Warsaw Uprising in 1944 appear in some sources but lack reliable documentation. Most accounts indicate the uprising was crushed before the gun could be prepared to fire. 47 shots, perhaps 48 depending on the source. That was the sum total of Gustav's contribution to the Second World War. 13 days of thunder at Sevastopol, then silence for the remaining 3 years of the conflict. The siege of Sevastopol produced horror on a scale that dwarfs Gustav's contribution, context essential for understanding how limited the supergun's impact ultimately was. Between June 2nd and 6th alone, German forces fired more than 42,000 artillery rounds, totaling nearly 2,500 tons of conventional munitions. Hundreds of German aircraft conducted sorties over the city, adding substantial tonnage of bombs to the defenders' misery. Day after day, the bombardment continued without pause. The Luftwaffe added hundreds of sorties, dropping substantial additional tonnage of bombs on the defenders. Gustav's 47 shells, each weighing between 4 and 7 tons, represented a tiny fraction of the total bombardment, impressive in individual effect, but statistically small in the overall campaign. The city was being destroyed by conventional firepower on a massive scale, and Gustav's contribution, however dramatic its individual impacts, barely registered in the larger arithmetic of destruction. Among the Soviet defenders was Lyudmila Pavlichenko, history's deadliest female sniper with 309 confirmed kills. She fought for 8 months during the siege, moving through the ruins of a city under constant bombardment, hunting German officers and soldiers with a precision that made her a legend on both sides. Her rifle weighed less than 4 kilograms. Her ammunition weighed grams. Yet she personally accounted for more than 300 enemy deaths, while Gustav, with its thousands of tons of steel and its thousands of supporting personnel, contributed 47 shells to a bombardment that achieved nothing conventional forces could not have accomplished. German propagandists broadcast messages trying to induce her defection, recognizing the damage a single skilled sniper could inflict. "Come over to us," they said. "We will give you plenty of chocolate and make you a German officer." When that failed, the tone changed to threats. "If we catch you," they promised, "we will tear you into 309 pieces and scatter them to the winds." A mortar fragment wounded Pavlichenko in June 1942. Around the same time, Gustav was firing its rounds into the fortifications she was defending. She was evacuated by submarine before the city fell, eventually touring the United States, where she became friends with Eleanor Roosevelt. The First Lady later visited Pavlichenko in Moscow after the war, one of the conflict's more unlikely friendships, born from a siege where the world's largest caliber gun traded fire with the world's deadliest sniper. Vice Admiral Philip Oktyabrski organized the defense of Sevastopol, drafting thousands of civilians into constructing fortifications and forming naval infantry units from sailors whose ships had been destroyed in harbor. His men endured not only Gustav's shells, but the full weight of German conventional firepower, month after month of bombardment that reduced the city to rubble. Approximately 18,000 Soviet defenders were killed and 95,000 captured when Sevastopol finally fell on July 4th, 1942. The city's loss was a catastrophe for the Soviet Union, but the defenders had tied down German forces for 8 months, forces that might otherwise have been employed elsewhere on the vast Eastern Front. On the German side, Lance Corporal Gottlob Beidemann of the 132nd Infantry Division recorded harrowing experiences in his memoirs. He describes anti-tank duels with Soviet armour at close range around the Mekhin-Sivy-Gori rail station, where he narrowly survived direct tank fire while Gustav thundered in the distance. For men like Biderman fighting with rifles at ranges measured in meters, the Supergun was a distant curiosity, something they heard but never saw, something that had no bearing on their personal survival. They knew a massive gun was firing somewhere behind them. They heard the distinctive thunder of its discharge rolling across the landscape, but their war was decided by grenades and bayonets, by machine gun fire and mortar rounds, not by shells fired from 16 kilometers away. Gustav existed in a different war from the one they were fighting. The firing crew experienced a strange combination of tedium and tension that characterized life with the world's largest caliber artillery piece. Each shot required extensive preparation by physicists and engineers, measurements of propellant temperature and atmospheric conditions, calculations of wind speed at altitude and chamber pressure. The elaborate preparations could consume an hour or more. Then came the loading sequence, lasting 30 to 45 minutes as shells and charges were hoisted into position and rammed home. The moment of firing arrived with startling suddenness. After all that waiting, the gun roaring, the shell arcing away toward targets they could not see, and then the measurements would begin again for the next round. German accounts published after the war became primary sources for reconstructing Gustav's history after both guns and all blueprints were destroyed. These testimonies preserve the operational reality of a weapon that existed more in propaganda than in practical military effect, detailed records of procedures that would never be repeated. The resource investment in Gustav represented a catastrophe of military economics, a misallocation that Germany could not afford at any point in the war, let alone as the conflict dragged on and resources grew scarcer. The combined development and production costs could have purchased well over 100 Panzer IV tanks, the reliable workhorse of German armoured divisions, or comparable numbers of Panther tanks, vehicles that could have made a real difference in the armoured battles of the Eastern Front, or Tiger tanks, the heavy vehicles that Allied tankers genuinely feared and went to great lengths to avoid, or assault guns, the infantry support vehicles that proved so effective in both offensive and defensive operations. The cost per combat shot was staggering, enough to build multiple tanks for every shell fired. Germany exchanged substantial armoured formations worth of resources for 47 artillery rounds. At Kursk in 1943, additional tanks might have changed the outcome of the battle. At Sevastopol, 47 additional shells changed nothing that conventional artillery could not have achieved. Personnel costs were equally severe. Thousands of men were assigned to a single weapon that fired fewer than 4 shots per day at maximum rate. Those men could have crewed dozens of conventional artillery pieces, providing fire support across an entire corps front. The 1,350 tons of steel in the gun alone could have produced dozens of armoured vehicles. Vehicles that could move, that could protect themselves, that could engage multiple targets. Wehrmacht officers recognized the waste. Many felt the gun was not worth the resources its construction consumed, let alone the manpower needed to deploy it. The weapon was widely mocked by German generals as a prestige project that was far more trouble than it was worth, a monument to Hitler's ego rather than a practical implement of war. But Gustav had become Hitler's personal obsession. He visited firing demonstrations and posed for photographs beside the massive barrel, dwarfed by the weapon he had willed into existence. He spoke of it with proprietary pride, his steel fist that would shatter any enemy. He brought foreign dignitaries to witness test firings, displaying the weapon as proof of German engineering supremacy. Cancellation remained politically impossible regardless of military reality. To abandon Gustav would be to admit that his judgment had been wrong, that the resources had been wasted. Hitler could not accept such an admission. Gustav belonged to a pattern of Nazi superweapons that consumed vast resources for minimal military return. The Maus super heavy tank weighed 188 tons, too heavy for any bridge in Europe, too slow to be tactically useful, never deployed in combat despite consuming resources that could have built dozens of conventional tanks. The Landkreuz P1500, nicknamed Monster, was designed as a 1,500-ton vehicle to carry Gustav into battle, an absurdity built upon an absurdity. Albert Speer, the armaments minister, cancelled it in 1943 as an obvious waste of resources. The V-2 rocket program killed more slave labourers in construction than enemy civilians in deployment. 12,000 forced workers died building weapons that caused perhaps 6,000 deaths total, a weapon whose only military contribution was terror. General Heinz Guderian, the architect of German armoured warfare, later wrote in his memoirs that Hitler's fantasy led him into the realm of the gigantic. Gustav embodied this fantasy more completely than perhaps any other weapon of the war, a gun that was biggest because biggest was considered best. The Allied intelligence failure regarding Gustav was extraordinary and speaks to the effectiveness of German security measures. Normal classification as top secret was deemed inadequate for information about the gun. A special secrecy order required all information exchange by courier only. No documents were transmitted by radio or telegraph, eliminating any possibility of interception. Deliberate misinformation was spread to confuse any potential leaks, false reports suggesting different weapons or capabilities. Military historians have concluded that extreme secrecy and deliberate misinformation was such that Allied intelligence never learned of this new weapon during the war. No British codename was ever assigned. No American analysis was ever produced. The Soviets experienced Gustav's effects at Sevastopol without identifying the specific weapon responsible, attributing the destruction to the general artillery bombardment rather than to individual shells. This secrecy held throughout the war. Only when American troops discovered Gustav's ruins in April 1945 did the Western Allies learn what Germany had built. The gun was found in a forest approximately 50 kilometres southwest of Chemnitz, destroyed by its own crew to prevent capture. Post-war analysis allowed a comprehensive assessment of what the Allies had faced without knowing it. Soviet specialists studied the wreckage in the summer of 1945, photographing components and measuring dimensions before remains were transferred to Mersburg for detailed examination. After that, the trail of the gun was lost. The world was robbed of a unique museum piece, the largest caliber rifled weapon ever used in combat, reduced to scrap by the men who had served it. A few artifacts survive. The Imperial War Museum in London acquired a complete 800mm shell from Krupp in 1947 during the company's dismantling, a massive cylinder that dominates any room containing it. Additional shell casings exist at the Polish Army Museum in Warsaw and reportedly at the Stalingrad Battle Museum in Volgograd. The smaller K5 railway gun Anzio Annie was captured intact and remains displayed at Fort Lee, Virginia, offering a glimpse of German railway artillery preserved for history, though nothing approaching Gustav's scale. Neither Gustav nor Dora survived the war. Both were destroyed by German forces to prevent capture, ending their stories without the preservation that might have made them museum attractions for generations to come. The final months of Gustav's existence were marked by idleness and eventual destruction. After Sevastopol, the gun was deployed toward Leningrad but never fired, sitting assembled and ready while tactical conditions prevented its employment. From September 1943, it sat in storage near Chemnitz, awaiting orders that never came, its crew maintaining equipment that would never again be used. A final test firing reportedly occurred at the Rügenwalder Proving Ground in 1943. Then silence, the weapon sitting unused while the war turned decisively against Germany. Dora's trajectory was equally anticlimactic. Transported to the Stalingrad area, the gun was withdrawn without firing when the Soviet counteroffensive threatened to encircle German forces. The weapon that had been positioned to reduce Soviet fortifications became instead a liability requiring evacuation before it could be captured. The irony was complete. By March 1945, Dora had been transferred to Grafenwöhr, where German engineers destroyed it in April to prevent American forces from seizing it. Gustav met its end in mid-April 1945. German engineers, knowing the war was lost and that American forces were approaching, made the decision to destroy the weapon rather than let it fall into enemy hands. American troops arrived shortly after to find wreckage in the forest, the remains of the world's largest caliber gun scattered across a German woodland, massive barrel sections, twisted carriage components, the debris of years of engineering reduced to scrap in hours. Soviet specialists joined the examination that summer, cataloguing what fragments remained before the debris was collected and eventually lost to history. A third variant had been planned, the Langer Gustav, with a smaller caliber and longer barrel designed to fire rocket-assisted shells at extreme range. From positions near Calais, it could theoretically have struck London. RAF bombing raids on the Krupp factory in Essen in February 1943 damaged the weapon beyond repair before it could be completed. The Allied strategic bombing campaign, so often criticised for its indiscriminate destruction, had killed one superweapon before it could be born. Modern historians deliver uniform verdicts on Gustav's military significance. A technical marvel but a military folly, declared one analysis. The gun was a flop. A solution looking for a problem, concluded another. Museum observers have noted that increased efficacy of aerial bombardment made these large guns obsolete, a judgment that applies with particular force to Gustav. What aircraft could do flexibly and repeatedly across multiple targets, Gustav could only do slowly and laboriously against fixed positions. The future of warfare lay with mobility and air power, not with massive fixed artillery pieces that required weeks to position. 47 shots in 6 years of war, one target successfully destroyed in a manner that arguably could not have been reached by other means, thousands of men tied up for each deployment. Weeks of preparation for 13 days of firing. resources that could have built over 100 tanks. The largest caliber rifled weapon ever fired in combat spent weeks preparing to fire 47 shells over 13 days, then never saw action again. This is not the record of a wonder weapon. This is the record of a prestige project that consumed resources Germany could not afford, served purposes that have become obsolete, and achieved results that conventional forces could likely have accomplished at a fraction of the cost. The Schwerer Gustav represents something important about the Nazi approach to warfare: the belief that spectacle could substitute for substance, the conviction that size indicated power, the willingness to continue pouring resources into failing projects because admitting failure was politically unacceptable. These tendencies produced not just Gustav, but an entire category of wonder weapons that consumed German industrial capacity while contributing little to German military effectiveness. June 1942. The Crimean Peninsula. Deep beneath Sevastopol Bay, Soviet ammunition handlers go about their duties in tunnels they believe are invulnerable. They have held for 8 months. They will hold forever, or so they think. They never hear the shell that kills them. Fired from 16 kilometres away by a gun weighing more than 1,000 tons, the 7-ton projectile bores through water and rock and concrete to find them. The magazine erupts. The tunnel collapses. Men who woke that morning confident in their safety die, without ever learning what weapon reached them. It was Gustav's finest moment. 47 shells fired in anger across 13 days, then 3 more years of idleness before German engineers destroyed the weapon to prevent its capture. The ultimate supergun, the steel fist that Hitler believed would shatter any fortification, reduced to scrap in a German forest shortly before American soldiers arrived to see what all the secrecy had concealed. The men beneath Sevastopol Bay never knew what killed them. Neither did Allied intelligence, which never learned of Gustav's existence during the war. Only history records the full absurdity of Germany's greatest gun, the weapon that took 5 years to build, weeks to emplace, and 13 days to exhaust its entire combat career. Some German generals mocked it as a prestige project. Modern historians call it a military folly. The numbers speak for themselves: 47 shots, 1,350 tons of steel, millions of Reichsmarks, thousands of men, and at the end, ruins in a forest, a shell in a museum, and the memory of a single magazine destroyed beneath the Black Sea. This was the Schwerer Gustav, the largest caliber rifled weapon ever used in combat, the ultimate superweapon, and one of history's most spectacular wastes of military resources. A weapon that proved, more clearly than almost anything else from the Second World War, that size alone does not win battles. That spectacle cannot substitute for practicality. That wonder weapons are worthless if they cannot be deployed quickly, cannot be aimed flexibly, cannot fire more than once an hour. Germany learned this lesson too late, pouring resources into giants while their enemies built weapons that actually worked. The greatest gun ever fired in combat fired just 47 times, and then the war moved on without it.